Okay, finally, I think we're ready to start. We're looking at the wrong questions. Let's start with a sine and cos. Okay, if we look at this first question I have, it pertains to a cos and sine graph. So what I want to start with, if we have an equation y equal to a into sine, and I'm going to say bx. So we know a affects your amplitude, and b is the value that affects your period of the graph. Okay, that's dealing with our amplitude, and b affects your period of the graph. But if we have a horizontal shift or a vertical shift in a graph, if we have like x minus 30 degrees, this means that the graph has moved 30 units to the right. And if I put a +2 in the end, that means that the graph has moved 2 units up. So those are things I just want you to keep in mind, even as we would grow through this question. Okay, we're ready to read. It says the graphs of f of x is equal to -half cos x. That's your f graph. Let's look at that f graph. I think you can see that quite clearly. -half cos x. And then it goes on to the g of x, which is equal to sine of x plus 30. There's our sine graph. And it gives us the interval. And there is a point of intersection, which is 139 and 0.33. And the first question is write down the period of G. Before we go on, let's look at what the numbers represent. In the cos graph, we have a -half. So that affects the amplitude, which means the amplitude of this graph is now half. Minus also suggests that it's reversed, or it's a better word I think we would use is that there is a reflection of the original cos graph or the half cos graph. And x plus 30 means that the graph is moved 30 units to the left, as we would change the sign there. Okay, coming to this graph and this question. And if we look at the question, it wants to know from us, what is the period of G? Now, if we look at the graph of G, okay, there's no change in the period because the value in front of x is still 1. So our normal period for any sine graph is 360 degrees. So x plus 30 means that the graph has moved 30 units to the left, but there's no number in front of x, which means our period has not been affected. So the next question is write down the amplitude of f. We look at the f graph. We notice that the amplitude is your distance from the midline. And if we look at this graph, your amplitude is always positive. So we could say that the amplitude here is actually half. Okay, and if we actually go to the graph, okay, we can substitute x to be 0, and -half cos 0 will give you a -half. Okay, so we'll notice that that's our midline. Your maximum distance moved is half. Determine the value of f180 minus g180. So let's go to 180. I think you can't see that. Okay. So if we look at 180, they don't give us the value. So the way we're going to work it out then is to actually substitute. In other words, if I take the value of f, sorry about that, just want to get my PowerPoint jumped. So if I go into the graph, if f of x if f of x is equal to minus cos x. So what we're going to do is find cos 180. Type that in the calculator. And then we're going to find g of x, which is actually equal to sine x plus 30. So we're going to use our 180 plus 30. And if we do that on our calculator, f of 180 minus half cos 180 on your calculator will give you a half. And then sine of 210 gives you negative half. So the question now is to find f of 180 minus g of 180. So we will say it's a half minus half, and that actually gives us 1. Okay, we're going to the next question. And the next question wants to know is, use the graphs to determine the values of x in the interval 0 to 180, so they're restricting us, for which f of x minus 10 is equal to g of x minus 10. So if we look at our graph as it looks right now, okay, what we are doing is shifting the graphs 10 units to the right. Okay, so if we move the f and g 10 units to the right, if we look at 10 units to the left, it will give us the answer we're actually looking for. So if we're not sure about that, you can also use your calculator to assist you. Okay, and if we look at our graph and what we're trying to represent, all right, they want to know, sorry about that, if we look at the graph, we know they want to know is when is x minus 10 equal to, so it's a point of intersection of the graph that moved 10 units right. But let's not worry about that. Where does this graph actually intersect right now? And we know that they intersect at a point 130,9. That's what it's telling it. So if we move the graph 10 units to the right, that will now add on 10, and that becomes 140.9 degrees. So that will be the value of x. The next question is a little bit more tricky. So we have, when is root 3 x plus cos x greater and equal to 1? So root 3 sine x plus cos x is greater than equal to 1. So normally what we do is we associate this with what we call special angles. So if you remember your special angles, remember that sine 30 is half, and sine 45, you can check on your calculator, is root 2 over 2. And then we know that sine 60 is what we want to look for, which is actually, if we use your calculator, you'll find your value. So very quickly, let's write that down. We know sine 30 is half. Let's get some special angles out. Sine 60 is root 2 over 2. Sorry, 45, that is. Okay. And sine 60 is actually root 3 over 2. So remembering our special angles for sine and cos, and then cos works backwards because of complementary angles. Cos 60 is actually not 60. The complement of 60 is 30. Cos 30 is actually equal to root 3 over 2. And then cos 45 is the same as that, which is root 2 over 2. And then cos 60 will equal to half. Now, why am I writing that down? So if I want to create a compound angle expression here, I have to use either I need a root 3 over 2. And I don't have root 3 over 2. So what I'm going to do is divide it by 2, right through. I'm allowed. It's an equation. So remember, there's a 1 here. We're going to divide that by 2. And we're going to divide that by 2. So now I have a choice. Root 3 over 2 is sine 60. Or I could use cos 30. And we also have 4 half. So it's really our choice which one we go with. So I'm going to go with the sine cos sine rule. So I'm going to say, right, we have sine x, bring the x first, and root 3 over 2 can be written as cos 30 plus cos x. Remember, your sine compound angle formula goes sine cos sine, and we can make this or equal to sine cos. And the angle here I'm going to use, because I want to keep the angles the same, so I'm going to use sine 30, which is coming from the special angles. Okay, I'm going to rub this out for space, since we know the special angles. And that is greater and equal to half. So you could either write sine cos sine, and then that reduces by the compound angle formula to x plus 30, which is greater and equal to half. And then I'm going to take my calculator out and find out what is shift cos half. Sorry, shift sine half. And that will give me the angle, because we are restricted only from 0 to 80. So if we actually work that out, shift sine half, remember that is also a special angle, okay? And we would get a reference angle to actually be equal to 30 degrees, okay? But now, remember, we're dealing with an inequality. So we have now x plus 30. That's the angle, which is equal to 30. So we will get x to be 0 here. Or we have a case where we have x plus 30. Remember that we can also have sine to be positive in the second quadrant. And the angle formula in the second quadrant is 180 minus 30. And that will give us 180 minus 30, subtract the 30 moves on that side, subtract 30 will actually give us 120. So those are the two values that we have identified. But the question is, when is this graph greater and equal to half? So putting it down into our inequality form, we can now conclude that x will be an element running from 0 to 120. And because we said equal to, we have to use a square bracket. So there we have it. And remember that sine of x plus 30 is actually the graph that we are dealing with. All right. And if you look at the graph, sine x plus 30 is our G graph. Okay. And there's our G graph, if I have to highlight it for you. Okay. But the question is, when is this graph greater and equal to half? So we actually have to draw the half line, and we know it's going to be from 0 to 20. Because if we substitute 0 at 0, this point here is actually half. Okay. So we can see that that's our line. And that will run to a point called 120. It is, as you can see above that. Okay, we're going to go to the next question on graphs. It says, in the diagram, 2 sine 2x is drawn for the interval. and it tells us that x is an element that is running from minus 180 to 180, and you can see the graph is drawn for you. So the first question is, on the same system of axes, on this graph, draw the graph of minus cos 2x. So that's for 3 marks. You can use the table on your calculator, or you can type it on your calculator. If we type in minus cos 2 times 180, at minus 180, if we substitute, we should be getting negative 1. Okay. If we substitute 135, minus cos 2, 135, we should be getting 0. If we substitute minus 90 into that equation, we should be getting a plus 1. And then if we substitute minus 45, we should be getting 0. And then at 0, we're coming back to minus 1. And I think from there, we can follow the pattern. Okay. And then we'll be coming back here, back there. And then we can't see that point. So we can quickly draw that. You can either use your table, or you can actually draw that. Okay. So the next question is, write down the minimum value. So just remember what graph we drew. This is our G graph, and that's our F graph. So write down the maximum value of f of x. There's our f of x. So if we take f of x is equal to 2 into sine 2x, and you can see the graph is drawn, the maximum value sitting there of this graph is 2. So they want to know what's the maximum value of fx minus 3. So that will actually be 2 minus 3, which will give us a negative 1. Okay, so that is our maximum value for f of x minus 3. The graph is actually shifted 3 units down. Okay, the next question, a little bit more tricky, dealing with a trig equation. So it wants to know when is, or determine the general solution of f of x is equal to g of x. So we're into trig equations. So what I'm going to do is equate both the graphs. The f graph is on the top, which is 2 sine 2x, which is actually equal to the g graph, which is minus cos 2x. You'll notice the angles are the same. And for us to relate sine and cos, one of the ways we can relate it, we know that tan is equal to sine over cos. So what I want to do is I want to divide both sides by cos 2x. And if I do that, I'm going to get 2 tan 2x is equal to minus, the cos's will cancel, minus 1. And then I'm going to divide both sides by 2, and I get minus half. So then we're going to use our calculator. Remember, tan is negative. If you want to know where tan is negative, it's negative in quadrant 2 and 4. But we don't have to worry about that because we know that the period of a tan graph is 180. So we don't have to check for both quadrants. We can use 180K. So if we find our reference angle, shift tan half will give us 26.57. So therefore we can say our angle, which is called 2x, is actually equal to 26.57. And for tan, it's negative. So I have to use my formula to get the first negative quadrant with. So remember, tan, what I said, is negative in quadrant 2, and that's a 180 minus your reference angle. So we don't have to worry about quadrant 4. You can use it if you want, 360 minus. But if you use our 180, because the tan graph repeats itself after every 180. We don't have to worry about quadrant 4. So 180 minus your reference angle of 26.57 plus 180k. Remember to say that k is the element of integers. And then we're going to divide by 2. So we're going to say x is equal to 180 minus 26.57 and divide that by 2. You should get 76.72. And we're going to divide the 180 by 2, which will give us a 90k. And that is what we're looking for, a general solution. Okay, so if we look at this graph, and they now want to know, hence determine the values of x for which f of x is less than. That means when is f below g, but only look from minus 180 to 0. So we're only concentrating on the left. So if you look at the graph on the left, and I want to draw it in, when is f, according to the question, when is f, sorry, not below g? So we're looking at f. So from this point, going to that point, we see f is actually below the red graph. So we need to identify this point of intersection. Okay. And remember, we just found the general solution. Okay, where the two graphs we have equated where they actually intersect. So I want to take that with me even as I work out this problem. So I just want to get some space here. And if this was a specific solution, what we would have done is we would have substituted values to find the points of intersection. Okay, so since we are working on the left-hand side, we're going to substitute -1. So if k was -1, we will get the first point on the left. And if you put k to be -1 in there, you should be getting minus 13.28. So there's our first point, minus 13.28. And next, I'm going to put k to be -2. And if I put k to be -2 in there, 76.2 plus 90 times -2, I should get x to be equal to minus 103.28. So there's our 103.28. So we are saying now that f is below g, running from minus 13.28. Sorry, we need our small number first. We work from left to right. So we're actually working from minus 103.28. Okay, there's our point. And that's going to the other point called minus 13.28. And it said, when is it less than? So there's no equal to sign. So we'll use an open bracket and say x is an element. And I know some of you want to know, can we write it in another way? Most definitely. In set builder notation, we could have said minus 13.28. And in this side, I have a minus 103.28. Okay, sorry. I see there's a question there, and I didn't see it. I was busy talking. So I want to take that question. So if the half was negative, then would that affect the restriction of x being between 0 and 180? I'm not sure which question you're referring to. Why did 2x not cancel to become 1 in the first equation, sir? Okay, it doesn't cancel because there's a sign in front. So you can't cancel the 2x's, all right? It goes with sine 2x. So you can't go and cancel the angle. You have to cancel with the trig ratio. All right, we see the famous tan graph. Remember, the period of a tan graph normally is 180 and not 360. Okay, so if we look at this question, it says that f of x is equal to, sorry, we skipped that very quickly. So we see there's a tan bx, which means that b will affect the period of the graph. And then we have cos of x minus 30 are drawn, and they give us the interval is minus 180 to 180, the point 91. So P is a point 91, it lies on the tan graph. Okay, use the diagram to answer the following question. The first question is to find B. Now I can do it two ways. I can use either substitution. So I'm going to start with substitution. So we know that f of x is equal to tan bx. And we know the y value, that's our xy. There's a point given on the graph where we can substitute. So the y value there is 1, and we get tan bx. And using your shift button, okay, sorry, not, oh, my mistake, sorry. On this one, our x value is 90. So we can use our shift tan 1 and work that, but that's not going to actually help us. So I'm going to go and do this a much easier way for you so that you can understand it before I go that route, okay? And what I want to say is that the period from here to here, you'll notice is 360. Normally the tan graph period is 180. So what we have done is double that. So therefore, y has to be equal to tan. Now, this is your normal tan graph giving you 180. So our new period, because it's 360, will be half x. So your new period now will actually be equal to 360, and we divide that by, sorry, it's, the normal period is 180, and we divide that by half, and that'll give us 360. So therefore, our value of b in this case is half. I'm not sure if that makes sense to you. Okay. Let me see if there's any comments coming through on that one. No comments at this stage. One is guy saying he's confused. One says he understands. So let's just go through that very quickly again, just to clarify any doubts. Just want to get my eraser out. Okay. Okay, so I said first we can actually start by substitution, and I want to go now the substitution route. So if f of x, which is y, is equal to tan bx, so f of x is 1, which is equal to tan b, and I said x here, if we look at the point P, that's the point I want to zoom onto, is 90. So to get rid of the tan, we use our calculator. We'll say shift tan 1. Okay, remember this is the entire angle. Shift tan 1 should give you 45. So B90 or 90B, you can say, is equal to 45. And then we can divide both sides by 90, and that gives me B to be half. So that's a quick way to do it via substitution. Or you could use it the understanding the period. The normal period of this tan graph, a normal period of a tan graph is 180, and we want to get a period of 360. So we got to divide by B to get the 360, and 180 divided by half will give you 360. In other words, we can form an equation there. 180 over B is equal to 360. And if we cross multiply, we'll get 360B is equal to 180. And if you divide both sides by 360, you will get the half we're looking for. I hope that's a little bit more clearer. Okay, thank you for illustrating that. So we got our B value to be half. So remember now we have the tan equation. Let's write it here. The tan equation now is f of x is equal to tan half x. The next question is write down the coordinates of A, the turning point of G. Okay, so if we look at that graph is called G of x is equal to x minus 30. So we know that, sorry, cost, we're writing cost. Okay, you notice that the amplitude of the cost graph is 1. So we know that if you look at this, that's your maximum value. That value is 1. Okay, so we can do it two ways. Actually, there's the y-axis. I'm moving too far back. Okay, so there's our value sitting at 1. Now, normally the cost graph starts at 1. So at x, when x is 0, cost is 1. So you shifted the graph 30 units according to this. So the graph has moved 30 units. That means very quickly I can tell you that that coordinates of the point A, I know the y value is 1, and that has to be 30. Or we could use substitution. Now we know that the y value is 1, so we can say 1 is equal to cos of x minus 30. So using our calculator, we can find the angle x minus 30. To get rid of a cos, you say shift cos 1, which will give you 0. And then you take your minus 30 on that side, you'll get a plus 30. Okay. Okay, the next question is talking about asymptotes. Now we know that if you look at this graph, the asymptotes here should be at minus 180. I'm going to actually draw it in. Okay, let's get another color. Say red. Here's our asymptote sitting there. And there's another asymptote actually at 180. Okay, so there's the asymptote at the moment. If we look at the asymptotes of this graph, they say rather than the equation of the asymptotes, okay, the normal graph without the normal tan graph that we have on the page there is x is equal to minus 180 and x equal to 180. Now let's have a look at what are they doing to this graph. Okay, so y is equal to 10 x plus 20. Now we're not worried about we're worried about the horizontal shift. The graph is actually equal. If we change the sign, is minus 20. So the graph is moving 20 degrees to the left. So if we say 20 degrees left, we're subtracting 20. That will become minus 200. And if we subtract 20 here, x here would be 160. But the question is only concentrate on the interval minus 180 to 180. Sorry, minus 180 to 180. So we'll only take the answer x equal to 160. It falls within the interval. So that is the equation of the asymptote. Okay, the next question pertains to range. Okay, and the question reads, determine the range of h if h of x is equal to 2gx plus 1. So let's start with what we know. What is the range of g of x as we see it right now? Okay, if we look at the range, the g graph is going to the maximum value of 1, and your lowest value to that graph will be -1. So right now, the range of g is actually running from -1 to 1. And we should say y is an element. So if we look at h of x, and they are now looking at that to be twice g of x. Don't need a bracket there. Let me just take that out. Plus 1. So what we're looking for is the plus 1 will move the graph 1 unit up. But then we have also 2. It's being multiplied by 2. So what we're going to do is the effect on the range. We look at -1, 1. If we multiply that by 2, we will get -2, 2. And then that caters for multiplication by 2, changing the amplitude. And then we're adding 1. So the graph is moving 1 unit up. So -2 plus 1 is a -1. And 2 plus 1 is 3. And that is our range for h of x. Okay, y is an element running from -1 to 3. So we've covered a tan, we've kind of covered a sine, and we've covered a cos graph. Okay, this graph is more about drawing a tan graph, which is, I think, one of the hardest graphs to draw for boys. So I think it's worth looking at. So it starts with, consider f of x. Okay, f of x equal to -2 tan 3 over 2x. Write down the period of f. So remember what I said, that the number in front of x, in this case 3 over 2, affects your period. So your normal period of the tan graph is 180. And then we're going to divide it by the number in front, which is 3 over 2. You can use your calculator, which will actually give you 120 degrees. So you can remember it as a formula. You take the original period and divide by the number in front of x. Okay, the next question is the point A, T2. The point A, so we know the x value there is t, and the y value is 2, lies on the graph. Determine the general solution of t. What we're going to do is substitute. So we know f of x is equal to -2 tan 2/3 x. So we know the y value is 2. And the x value is t. So firstly, I'm going to get rid of the -2 by dividing both sides by 2. And then I'm going to get tan 2 over 3t is actually equal to -1. So remember now that to get rid of the tan, we got to use shift. You can't start, the 2/3 is front of tan, so you can't work with that. You got to get rid of the tan first. Shift tan -1. So we want to get a reference angle out. Let's start with the reference angle. So if I take shift tan 1, and that should give me 45 degrees. So there's our reference angle coming out. But remember, tan is negative in quadrant 2 and 4. And that's a 180 minus and a 360 minus. So the angle itself, 2/3 t, if we look at the angle, 2 over 3t will actually equal to, so it's negative, I said, in quadrant 2. And the angle formula there is 180 minus 45. And plus So we don't have to look at the fourth quadrant if we use an interval of 180 k. And remember, k is the element of z. And what I'm going to do now is multiply to get rid of the 2/3, multiply by 3/2. So 180 minus 45 is 135. Okay, let's keep the 2/3 and do that in the next step. So we got a 135 plus 180k. And then I'm going to multiply right through by 3/2. So the 3/2 will cancel. 135 times 3 divided by 2 will actually give me a 90. I hope that's right. Okay. And if I look at, we said 135. Don't have a calculator with me, but I'm multiplying it by 3/2. And if I multiply that by 3, 135 times 3, 270 divided by, sorry, I think I've got that one wrong. Okay, we're going to multiply by, okay, I made a mistake on the question. So let me go back, guys. It's not 2/3. The question, I wrote down 2/3 is 3/2. So we have to go back. My apologies for that. So instead of saying 3/2, I wrote down the fraction the other way. So we got to start again. No one picked it up in my class. That's very bad. So the question is minus 210. It's 3/2x. Okay. Sorry, I'm on this question. Use the graph to determine. Sorry, 6.2. Okay. So the question here is not 2/3, but 3/2x. So we're going to do the same thing. Is just we change the fraction. And we're going to firstly, we substitute it. So we said t is actually equal to minus 210. And instead of saying x, we can say t. And then, sorry, not t. T is not on this side. On this side, we got a y value of 2. So then I said divide both sides by -2. And then we end up with minus 1 is equal to 10, 3/2t. And then get rid of the 10. What I said was shift 10 minus 1. So the shift 10, 1 gives me 45. And that would be our reference angle. But remember, 10 is negative in quadrant 2. So the angle 3/2t is actually equal to 180 minus 45. So that takes me into quadrant. And I'm going to put it down as 135 plus. And remember, for the tan graph, we use a 180k. So to get rid of the 3/2, we're going to multiply right through by 2/3. In other words, if I multiply that by 2/3, you'll see it cancels. So I'm going to take my 135 and multiply by 2/3. 135 times 2 is 270. 270 divided by 3 is 90. Plus, then I'm going to take my 180 and I'm multiplying by 2/3. 180 times 2 is 360. 360 divided by that is actually 120k. And that is actually my answer. Our general solution. Okay, the next question, if you're looking at it, it says draw the graph. Now, drawing the graph, you can either use, remember what I said, you can use the table on the calculator. And I'm sure now you know how to sketch tan graphs, so I'm going to skip that. If you really don't know how to use your calculator, let me know. We'll actually do it. So can I skip 6.3? The sketching one? And all you have to do is punch in the values of a calculator, put your dot and draw your line. Okay, so we're moving on. Use the graph to determine the values. Okay, we have to draw the graph to answer the next question, or we could actually work it out without that, all right? So I'm going to stop there because of time and get to the next question on 3D and 2D problems.